to look at limits. You've kind of looked at limits before. In the last chapter, we looked at asymptotes. So today we're going to look at this further. First couple questions are, can a person run faster and faster? Can a tree keep growing taller and taller? Or are there limits to these? Let's look at the first example. Let's say a bowl of soup is 101 degrees Fahrenheit. Let's say Sam measured the soup's temperature each minute for 5 minutes, and he came up with this recursive sequence to represent the rate of cooling. So the original temperature is 101, and it looks like we have 80% of the temperature the minute before plus 15. There's your rule. First question, is this sequence arithmetic or geometric? Does it have a common difference or a common ratio? This sequence is geometric, has a common ratio of 0.8 or 80%, so it's geometric. Since it does have this plus 15 right here, there's the shift in the graph, so this is called a shifted geometric sequence. Using your calculator, determine the temperature of the soup after 9 minutes. All right, let's go to our graphing calculator and type that in. So to type this in, you're going to start with the first term. Let me clear this. All right, so the first term is 101. Hit enter, so it's now our last answer. And then whenever you see u sub n minus 1, it's like using the last answer key, so we're going to hit second negative. So our last answer, we're going to take 80% of that, and we're going to add 15. So every time you hit enter, it's another minute after the soup has been sitting out. So here's after 1 minute, here's the temperature. And it says using your calculator to determine the temperature after 9 minutes. So there's 1 minute, 2, 3, 4, 5, 6, 7, 8, 9. So after 9 minutes, the temperature is about 78.5 degrees. Let's make this right here. 78.5 degrees, about. What happens if you keep hitting enter on your calculator? All right, let's try that. Let's see what happens to the temperature over time. So I'm just going to hit enter a bunch of times and see, does it go down to 0 or what happens to the temperature over time? So we keep hitting enter here, and it looks like it's starting to level off here. If you're watching the decimals, it looks like it's leveling off at about 75 degrees. Keeps getting closer and closer to 75. Okay, so if you kept hitting that, it would get closer and closer to 75 degrees. And maybe an explanation is that room temperature is 75 degrees and your soup doesn't get colder than room temperature. So it looks like it goes towards 75 degrees. Okay, so there's example 1. Example 2, let's say Monica and Jasmine are working at a pool for the summer. They need to add chlorine to the pool to prevent the growth of algae. The first day, they add 450 grams of dry chlorine, and they add 45 grams each day after the initial treatment. Each day, the sun burns off 15% of the chlorine. So first step, write a recursive rule. Okay, so let's say our first term is 450. And we're going to say that the amount of chlorine in the pool, we're going to take the day before, and it says the sun's burning off 15% of the chlorine. That means 85% of the chlorine is still left in your pool, so that's 0.85. And then every day we're also adding 45 grams of chlorine. So this is a shifted geometric. Again, it's geometric because our rate is 85%, and it's shifted plus 45. Use your calculator to find the amount of chlorine after 1 day, 2 days, and 3 days. Okay, so again, let's go to our calculator. Type in your initial value, 450. So let me clear this. So we have 450. Hit enter. We're going to type in our sequence here. So we're going to hit second answer times 0.85 plus 45. Okay, so after 1 day, it looks like there's 427 grams. Here's 2 days, 408.375 grams. Here's after 3 days, 392.12 grams of chlorine. All right, use your calculator to find the amount of chlorine in the long run. Okay, whenever you hear long run, you just hit enter. And let's see if this has a limit, just like the soup problem had a limit at 75 degrees. We'll keep pressing enter and see if there's a limit too for the chlorine in the pool. Okay, this one right here, it looks like it's starting to slow down a little bit. Looks like the limit might be 300 grams of chlorine. Okay, so I'll stop it there. And it looks like there, what would be the equation of the asymptote? Well, here's a picture of the graph. And here's 300, so it does meet 300. So the asymptote looks like it might be, what, 299, we'll say, right here in asymptote. So we're going to say the equation is y equals about 299.9 repeating maybe, because it does reach 300, it doesn't go lower than that. Okay, last example. Each year, SLP Nursery owns 65 pine trees. Each year, the nursery plans to sell 20% of its trees and plant 5 new ones. First step, write a recursive formula rule that represents the situation. Okay, so the first year, 65 trees. For each year after that, we're going to take the year before. And if you're selling 20%, you're still owning 80% of your trees. And you're also planting 5 new ones. So it's shifted geometric. Use your calculator to find the number of trees you will have in the long run. Okay, so let's go to our calculator. Type in our first term. So our first term is 65. And type in your equation right here. So it's going to be 80% of the last answer plus 5. And again, every time you hit enter, it's another year. Just keep hitting enter and see if there's a limit. So that does it for the notes on limits.